And as we begin our little focus on radical equations, by the way, this will just be a one-day event, so we're not going to be doing this for like 5 days. It's just one day. Here's a little radical equation that I'm sort of daring you to solve. Five plus the square root of x minus 4 equals 2. Why am I daring you to solve this? Well, it kind of looks like just a good old square root equation, but sort of lurking in the background, there's something special about it. Are you willing to try to solve it? I'm assuming that you've seen some exposure to this, but maybe just to give you a little jump start, all you got to do is subtract 5. All you got to do is square both sides so you can eliminate the square root. Do you think you can solve it? You're just going to subtract 5. You're just going to square root both sides. But there is something special about it. Okay, now, again, maybe you've seen something like this. I don't know if it's been a year, 2 years. Maybe you haven't. But algebra says that I can kind of do like inverse operations. So yeah, subtract 5. That's just going to give you -3. Not a big deal there. Now, I hope that you square both sides. That is a little fancy, but when you square both sides, you eliminate the square root. So that's, of course, the idea. So that I can get x minus 4. Careful here. This is not -9, but rather +9. And then, of course, if you add 4, you get 13. But there's something special about this. In fact, there's actually something especially wrong about it. Wait a minute, how could this be wrong? Okay, well, it's not wrong that we did all this algebra, subtracting, squaring, and adding. None of the algebra we did was wrong. Getting the number 13, again, the work that we showed was fine, but there's something wrong about 13. My gosh, what could be wrong about it? It doesn't equal 2 when you plug it in. How can that be? What the heck? Let's plug it in and find out. We commonly call this a check. But what happens? You plug in 13, you're checking to see if it equals 2. Well, nothing too fancy right now, just the square root of 9. But geez, that ends up being 5 plus 3. And I guess I can say you are correct, or we are incorrect, because 5 plus 3 does not equal 2. And so we have a problem. Now, I always kind of hope, honestly, that a student asks that. I kind of hope that everybody's wondering, wait a minute, shouldn't it be plus or minus? You know, like sort of plus or minus 3? Is that basically what we're suggesting? Okay, let me try to help you guys understand something that sometimes it can be hard to understand, but I want to try to make it simple. This equation was given to you as 5 plus the square root of x minus 4. Obviously, right? But what I mean is it wasn't given as 5 plus or minus. Now, students will say, yeah, but I thought it was always plus or minus. Plus or minus is if you're solving an equation, and if you're solving an equation and you put the square root into the problem, if you put the square root into the problem, then you get 2 answers. You get plus or minus 4, because plus or minus 4 is going to solve this equation. There's a fine difference though, and the difference is that the problem was given to you as a square root. More importantly, it was given to you as the plus only, just like it wasn't given as the minus. By the way, if it was given as the minus, guess what? This would work. So we can't put a plus or minus into the check because the square root was given to us. And what do? Well, what we do is we realize that we have a new type of equation, a radical equation. And sometimes radical equations will have an extraneous solution. This is known as extraneous. Extraneous is kind of a fancy word for extra, or maybe more correctly, extraneous, right? Yeah, I had that spelled right. Extraneous, meaning that it's literally not a solution. It's not a solution. Okay, now this would be something that you may want to even add as a separate little statement, but basically you can end up with a solution that doesn't work. You can end up with a solution that doesn't work. Okay, again, radical equations sometimes give us extraneous solutions. Okay, now listen, it's not like the sky is falling. It's not like all of a sudden everything you've learned has been erased. It's actually just a little new idea that this can happen. It's okay. It doesn't happen all the time. Obviously, I gave you a problem where it did happen. And the other thing is, since 13 is extraneous, which means it's not a solution, there's no other solution for us to choose from, which means that there is no solution for this entire equation. There is no solution for this equation. It's interesting. There's no number that will ever work for x. Okay, now again, this is not like this happens all the time, but it is something that, as noted up here, it can happen. Let's look at another radical equation. I think once you're done, well, when we're done with this little lesson today, you'll say, okay, this isn't too bad. Some of today is just realizing what to do if you get some certain result. Make sure you copy this correctly. This is negative 27 equals 3 times. This 3 right here is a coefficient. 3 times the cube root. Now, you've probably seen cube roots, but again, maybe not as super familiar. Basically, that's not a square root, but it's a cube root of x plus 4. It's still a radical equation. Now, the rule of thumb is that you always want to isolate the radical. It's pretty obvious what the radical is, but when I say isolate the radical, that means that you want to move those numbers away. In fact, dividing both sides by 3, it's pretty easy, but it definitely is what you want to do first. You divide both sides by 3. You always want to isolate the radical. Now, the reason we're isolating the radical is so we can then power the radical away. We can raise both sides to an exponent, in this case, an exponent of 3. So you always power away the radical. So we cube both sides. Cube both sides. Get a nice little cancellation that I'm sure you would expect. Leaves us with just x plus 4. And over here, it leaves us with some gigantic number, negative 9 to the 3rd power. Make sure you know your calculator. You want to use the exponent button. The exponent button might look like a little caret top key, or maybe it looks like y to the x, but you do end up with negative 729. Again, make sure you know your calculator. I don't mind helping you out if you're having trouble finding that. You still have to subtract 4. Again, pretty easy, but you still have to subtract 4, and now you're staring at negative 733. something has kind of been exposed. It's the fact that a radical equation might give us an extraneous solution. What that actually means is that you have to check your answers. I know it's kind of like a pain once you realize this is what you have to do, but you have to check your answers. Okay, now, when it comes to checking your answers, it's going to be up to you how you decide to do this. What I mean is some people do this completely on a calculator. Some people will show some work. But I'm just telling you that you actually have to check your answers if you kind of want to be sure. If you want to be sure. Okay. Hey, cube root of negative 729. Now, there's a couple things you could do right here. You could realize that we just did that backwards a second ago. But I also want you to just know your calculator. There is a cube root button on there. Okay, even if you have just a regular kind of a scientific calculator, there should be a cube root button. And it might look like literally the cube root with a little 3, or it might look like an x root. If you're going to activate the x root, you would have already had to have typed the number 3 to go in place of the x. I'm going to just use my cube root button. By the way, if you have a graphing calculator, I know a couple of you do, that was in the math menu, but you have to find it. For some of you, it's in a menu. For some of you, it's just on the keyboard. Obviously, it's going to come out to negative 729 because you're just going back the other direction. Yes. Again, I know some of you have the X root key. It's fine. Just you have to type the 3 first because that 3 will then get inserted in there for X. There's going to be some other times this year where you're going to have to be comfortable with some certain buttons on your calculator, so just get to know it. But I think we're good. Sometimes people start to question what they know, but 3 times negative 9 is negative 27. So it works, okay? It's not extraneous. I had a little statement up here to just kind of drive this home. Isolate the radical. Isolate the radical. You always want to isolate the radical before doing any other algebra. That seems like a basic idea, but as you'll see in this problem, it's the only way to be successful. You always want to isolate the radical first. Okay, now take a careful look. I've got the square root of x plus 7 minus x minus 1. Square root of x plus 7 minus x minus 1. Make sure that you understand the square root is only on the x plus 7. Okay, this is a little higher level problem. What we've done so far hasn't been that super duper, but there's something a little higher level here. But you have to isolate the square root of x plus 7. That means that that minus x and the minus 1 need to go over to the other side. I would expect that you guys can comfortably just add and end up with an x and a 1. Okay, but I have to do that first. Why do I have to do that first? Well, now when I square both sides, now obviously I'm going to square this side, which cancels out the square root. But when I square this side, the yellow parentheses were added by the teacher. I'm going to be squaring a quantity. Be careful. Okay, when I square the right side of the equation, it's like squaring a quantity, otherwise known as the FOIL method. Okay, these cancel out. That's easy stuff. Those cancel out. But over here, I have to think x plus 1, x plus 1. Okay, don't just square x and 1. That's a math teacher's nightmare. Remember, I wake up screaming at night. But if you do the FOIL method, then you'll be walking on good water here. Okay, x squared plus x is 2x. So x squared plus 2x plus 1. Now, what did we do? Just like I say to my dog, what did you do? And he sort of just wags his tail. He doesn't know. But what did you do? You just made a polynomial. Why am I pausing here? You just made a polynomial. You made an equation that looks like the type we've been solving in the first half of the chapter. Okay, it's actually a little bit of an easier one, but like you should look at this equation and you should say, that needs to equal 0. That's a polynomial. That's going to be factored. Okay, I kind of gave away the secret here, but you got to make it equal 0. You got to get it set up for factoring or whatever. When I say whatever, maybe you could use the quadratic formula. Maybe you could use some other strategy that you're hopefully doing on that assignment. But don't overthink this. This is just a basic, it's just a basic factoring polynomial. Again, before we finish this, just think with me that you could have done other strategies here. All the strategies that we just talked about in the last about 6 or 7 days. I'm sure there's going to be a time where you have to use the quadratic formula to finish one of these. Okay, that time is not this one because all I got to do is put a +3 and a -2. But we're solving it like a polynomial. That's kind of neat. We end up with a couple answers here, -3 and 2. We end up with -3 and 2. Okay, now, I hope you get this. I mean, I'm rooting for you. I hope you get it that you have to check these answers. Is somebody going to forget? I don't know. I hope not, but sometimes it happens. So I got to take -3, like it or not, and I got to plug it back into the original equation. Then I'm going to take 2, like it or not, and I'm going to plug it back into the original equation. Like I said, some people do this on a calculator. Some people will show the work. Some people do it mentally. What I'm trying to show you, though, is you have to go back to the original equation. Back to the original equation means the one that was equal to 0. Careful with your negatives, careful with your square root, do the math. And even myself, when I look at that, I'm kind of like, wait a minute, did I make a mistake? Well, no. -3 does not work. -3 does not equal 0. Darn it. Okay? But again, you kind of have to trust what you did, and you have to say, well, I guess that's not right. Now, just because that one's not right doesn't mean the other one is right. Got to be careful. You can't just assume that one, if not the other, or vice versa, because it could be the case that both of them don't work. It could be the case that both of them do work. Are you hearing me here? There's all kinds of possibilities. I just have to check it. And this one seems a little bit more satisfactory. If you kind of see that math, it's clearly going to be 3 minus 3. And so that one does work. A lot of times what kids will do is they'll cross off the one that doesn't work. They'll maybe circle the one that does work. If you don't circle it, I'll assume that you want it. But I crossed off the one that didn't work, and I did choose to circle the one that does. What's up? I mean, it might be helpful for everybody.
Do you have to keep the 1 in the equation? The -1?
So I did -2 minus 1. I actually did the -2 minus 1 and got -3. I went ahead and did a little bit of simplifying.
I just read the wrong number.
I'm glad you're asking. Now, I want to do one more of somewhat this variety. Somewhat this variety means that it's a little harder. How about the square root of 2x plus 3 plus the square root of 2x equals 3? Of course, this one seems to right away have more square roots. It's got more radicals. Listen, I kind of learned throughout the years that I better show a mistake right here. I'm going to make a mistake. It's a very common mistake. Students mean well, but it's bad algebra. You can't just kind of like square everything. Okay, you can square both sides, but by squaring both sides, like squaring like the whole side, you can't then just distribute the square. So unfortunately, it's not as easy as just kind of wipe out everything with a square. Actually, what you want to do is follow this simple statement. Maybe you didn't really realize why I put that up there because it's so basic, but you want to isolate. Now you say, yeah, but Mr. Miller, there's two of them up here. Okay, well, actually isolate one of them. I promise if you isolate one of them, we'll be able to get something rolling here. Okay, so basically I'm going to subtract the small square root. By the way, I could have done this the other way. But I'm choosing to isolate the big one just because. Now, this is different. When I square both sides at this juncture, I can get rid of a square root. I mean, the whole idea is to get rid of these radicals, but now I can get rid of one of them in one quick swoop. So we're on to something. Now, over here, don't just square everything. You're back to kind of what we said you can't do in the first place. Over here, we have ourselves another FOIL method, except it's of a somewhat higher degree because obviously we've got this square root hanging out. All right, don't be scared of foiling this. 3 times 3, we all know, is 9. 3 times negative square root. 3 times negative square root is negative 3 square roots. Now, 3 times this negative square root, notice that I'm pointing at this combination, is another negative 3 square root. What I'm trying to get us to realize is that eventually we're going to end up with negative 6 square roots. And if you're comfortable just moving to that step. Now, the last piece of the FOIL basically is the negative square root times negative square root. Now, this can be a little fancy, but first of all, negative times a negative is a positive. Second of all, because they're both the same, maybe you've either learned or I can tell you that they're going to cancel out. When I say cancel out, we're going to end up with just the 2x. Because when you take the square root times the square root, you end up with the square root of 4x squared. And the square root of 4x squared is going to just trickle back down to 2x. And students will often just say that it cancels out. Okay, take a look, because it's not that bad. We have a square root. Okay, look, we have a square root. What am I trying to say? We just need to kind of like, I'll say sort of start over, but maybe more of just pick up where we left off. That means isolate that square root. Okay, can you isolate that square root? Well, first of all, these two x's happen to be exactly the same. So either you just say they cross out or you can subtract them. Next, I'm staring at a 3, a 9, and a -6 square root. So, well, again, just kind of want to isolate it. I hope that you're thinking about doing the opposite of 9 and the opposite of multiplying by -6. So the opposite of 9 is minusing 9. And the opposite of multiplying by -6 is dividing by -6. So we just kind of have ourselves like a little bit of opposite, and we get down to 1 equaling or root 2x.
You explain the making -9.
Making -9?
Like, why is that making 9?
Well, okay, maybe see if I can, if I'm answering your question correctly here. What I'm trying to do is isolate this. Since I'm isolating this, I actually want to get these numbers moved away. So this was a +9. I'm going to minus it away. This was a multiply. I'm going to divide it away. I got you. Why didn't we set it equal to 0? Honestly, again, because we're trying to isolate so that I can square. Okay, remember, our whole goal is to square both sides one more time. And don't be fooled, you get 1 equals 2x. That's fine, I get 1 equals 2x. That means x equals a half. X equals a half. And we should check it. We should check it. Now, this one I'm just going to kind of do mentally, because if you plug a half in up here and a half in right here, even though it's a half, it actually cancels out nicely to just be 1 plus 3. And then over here, just 1. And if you think through the square root of each of those, you'll end up equaling 3. So it does work. Thank goodness we did all that. It does check. Make sure that you are truly checking, even though the teacher this time just did it mentally. Okay, now a strategy that I've used a lot in this chapter, and I know it gives you kind of like an extra thing to do, but I'm trying to help you, is an exit ticket. And I'm going to stick with that strategy. I'm trying to get you to think about getting one of these correct. As you can see,